Welcome to week 2 of our AI learning journey. In this video, we will explore the fundamentals of machine learning, focusing on supervised learning, and experiment with basic machine learning algorithms using Python and scikit-learn. Supervised learning is one of the most common types of machine learning. It involves training a model on labeled data, which means the dataset includes both input data and the corresponding correct output. Supervised learning can be categorized into two main types, classification and regression. Classification tasks involve predicting categories, such as identifying whether an email is spam or not. Regression tasks involve predicting continuous values, such as forecasting house prices. Now that we have a basic understanding of supervised learning, let's move on to a hands-on experiment. In this segment, we'll work with a code example focused on classification using the k-nearest neighbors (KNN) algorithm. The KNN algorithm is chosen for its simplicity and effectiveness in classification tasks. The k-nearest neighbors, or KNN, is a simple and intuitive algorithm used for classification and regression. It works by finding the k closest data points to a given input and making predictions based on the majority class or average of those neighbors. We'll use KNN for classifying iris flower species in our experiment. Let's go through the steps of our experiment with KNN for classification. Step 1. Install required Python libraries. Step 2. Load the dataset. First, we load the iris dataset, which contains measurements of iris flowers and their corresponding species. We use the load_iris function from the scikit-learn.datasets module. This function returns a dictionary-like object containing the features and target values of the dataset. The dataset includes 4 features: sepal length, sepal width, petal length, and petal width. These are the input values, represented as x. The target variable, y, is the species of the iris flower, with 3 possible species, setosa, versicolor, and virginica, encoded as 0, 1, and 2 respectively. Step 3. Split the dataset. Next, we split the dataset into training and testing sets to evaluate our model's performance on unseen data. We use the train_test_split function from the scikit-learn.model_selection module. This function takes the input features and target values, along with the test size and random state, to split the data. We use 80% of the data for training and 20% for testing. This split allows us to train the model on one part of the data and evaluate it on another part. The x_train and y_train variables are the input features and target values for the training set, while x_test and y_test are for the testing set. Step 4. Train a KNN model. We then create a k-nearest neighbors classifier with k equals 3 and train it on our training data. We use the k-neighbors classifier class from the scikit-learn.neighbors module. The fit method trains the model on the training data. Step 5. Evaluate the model. Finally, we make predictions on our test data and evaluate the model's accuracy. We use the predict method to make predictions and the accuracy_score function from the scikit-learn.metrics module to calculate the accuracy. The predict method takes the input features of the test data, and the accuracy_score function compares the predicted values with the actual target values. We use accuracy as our evaluation metric, which measures the proportion of correct predictions. The predict method takes x_test as input and returns y_pred, the predicted target values. The accuracy_score function compares y_test, the actual target values, with y_pred, the predicted values, to calculate the accuracy. Let's see how well our model performed. This concludes our hands-on experiment with the KNN algorithm for classification. Stay tuned for next week's deep dive into deep learning and upcoming quizzes for week 2 of machine learning. If you enjoyed this video, please like, comment, and subscribe for more AI content. Thank you for watching, and see you next time.